Object-oriented languages are so common in the programming world today that it's easy to forget it wasn't always this way. My first programming job 25 years ago was writing assembler and COBOL on mainframe computers. This wasn't an object-oriented language. These were procedural languages, a big list of tasks to perform, a process. All the data for your program was defined in one section, and all the logic was defined in a different section. Object orientation is another way of solving this problem. Instead of defining one massive process, you split your program up into self-contained objects that cooperate with each other. Each object contains its own data and its own logic to act on that data, and then they communicate between themselves. You cannot avoid object orientation. You can't write an iPhone program without knowing what these things mean. But it does bring with it a few concepts and some jargon we need to know so that we can speak the same language when talking about it. The first thing is classes and objects, and we can't talk about one without talking about the other. A class is the definition of something in your program. It's a blueprint, it's a description. It describes what exists, what it can do, and how it's constructed. You'll write classes to represent different parts of your program. If you wrote, say, a restaurant review application, you might write a class to represent a restaurant, and a review, and a user. But it doesn't stop there. Classes also exist to represent the visual parts of your program, things like buttons and text fields and windows. And they also represent invisible things like dates and time zones, and things internal to our program like arrays, and even things we haven't talked about yet like view controllers. But all classes detail two different things: attributes and behavior. What are something's characteristics or attributes, and what it can do, its behavior. So a person class might have an attribute of a name, a height, weight, a gender, and an age. And its behavior would be that a person can walk and run and jump and speak and sleep. These can also be referred to with other names. It's very common to hear the attributes also described as fields or properties, and behavior very commonly called operations or methods. And we'll use these terms, properties and methods, a lot going forward. Now, the class describes things in abstract. They say that a person class has a name, but it doesn't say what that name is. And that's because the class is just the description of something. It's like that architectural blueprint, but the object instead created from that class. And one class can create multiple objects, just as you can use one blueprint to create multiple buildings. And obviously there's a sequence there. First, the class is defined, and then the object or objects are created based on that class. So an example might be if you've defined a class for a button, which describes a button having a height and a width and text and a type and a color, then you can create multiple objects based on that class that can look different from each other but share the same common behavior. Or if you have a person class, you create one object called Alice that's 150 centimeters, 60 kilos, female, 28, and start creating multiple what are called instances of that. You'll often hear that term used as well as object. Then an object is an instance of a class. The process of creating an object is called instantiation. Now, you don't have to write all the classes you use. Apple will provide many classes for you, things to handle dates and strings and buttons and text fields, and you'll create instances of those classes to have objects to work with. But you will create your own classes and objects to tie them all together in some meaningful way. And the process will typically be, you'll write the class, unless Apple has already written it for you. You'll then create the object that's based on that class. You might create one, you might create multiple. You'll then use those objects. You'll access the properties of the object. You'll use the methods of that object, and then you will dispose of the object and clean up after yourself. The iPhone is very picky when it comes to memory usage, so you have to be very careful. We'll see exactly how to write this code shortly. Now, if you've done object orientation before, you'll know that there's a tremendous amount of jargon, and there's quite a few terms worth covering as we go forward. Let's do this by talking about a PIE, or APIE. It's a useful phrase to remember four key terms in object-oriented programming: abstraction, polymorphism, inheritance, and encapsulation. Now, if this is the first time you've come across these, you might find that somewhat intimidating, but I'm going to talk about them very briefly. Abstraction is the idea of reducing details to focus on core concepts. It's what allows us to think about all sorts of different individual specific people and then abstract those details out to properties and methods. The person class has name, height, weight, gender, age, and they have behavior, the methods that they can do. Encapsulation is the idea of enclosing our properties and our methods, our data and our behavior in a class and then hiding most of that information from other classes. This is sometimes referred to as black boxing. It's the idea of keeping things private. We encapsulate them together in a class and we can interact with other parts of the system, but we describe what it is they're allowed to do. Inheritance. It's kind of the flip side of abstraction. If we're going a bit more abstract to define our classes, then inheritance is about specialization, and it's very common. Let's say you start off by defining a person class with a name and address and phone number and some behaviors in it. And then you realize you need another more specialized version called a customer. So you think, well, maybe I'll create a different class called customer. It's exactly the same as the person class, but it added a customer number. You didn't want to add that to your person class because not all of your person objects are customers. Now, you could do it this way, but that's not the way we're going to do it in an object-oriented language. Instead, what we do is we create a new class called customer, and we inherit from the person class. The phrase that we often use here is that the person class is our superclass. Other phrases you might hear are the person is the parent class or the base class. We're creating a customer class that is inheriting from person class, which means we have everything that the person class has. We just say, add a customer number to that. Add a new property or add a new method, add some behavior or some attributes. Not only that, but we're not limited to one. We could then create another class called employee and inherit from person. And the employee class has everything that the person class has, but it has employee ID and pay grade and perhaps some other different behavior. Now, if you're used to inheritance in other languages, it's very common that you inherit classes all over the place. You may be surprised to learn that in inheritance in Objective-C, we don't quite use it as much. Instead, we'll use something called delegation a lot, which we'll get to later. But inheritance is a very common part of working with an object-oriented language. And then we have polymorphism, which means many forms. This is what a lot of people have a bit of a problem with. It's really about the idea of treating something as something else. Okay, what do I mean by that? Well, let's say with the idea of inheritance, we talked about a person class and a customer class. Let's take another example. Let's say we create an account class for a financial system, and that describes things like an account name and an account balance. We could then create more specialized version like a savings account, a checking account, an investment account. They all have a name, they all have balance, but they might have slightly different behavior. If you withdraw from a checking account, it may just subtract the money. If you withdraw from an investment account, it may subtract the money and also give you a penalty. If you withdraw from the savings account, there may be issues with interest. So they all are based on the one account, but they're a little different from each other. Polymorphism is the idea that if we have a process that has been written in our program that uses an account, it's been defined and says, I accept an account, we can pass anything into it that was based on that account class and it will work. We can pass an account in. We can pass a checking account in. We can pass a savings account in. We can pass an investment account in. And we don't really have to care about the difference between those classes because it will do the right thing at the right time. Polymorphism means the ability to treat something as something else and still work under the hood. Now, I've gone over this very quickly. We will come across these terms again. You're going to get very used to these. Your programs will have dozens, hundreds, or even thousands of objects existing and interacting with each other, and you're going to use many of the classes already created in the frameworks that Apple provide. So that's a very quick summary of some object orientation concepts so that we can move forward.